Well, greetings, Mr. Kolazar's class. Our last section of Chapter 11 is going to be on percent yield. And the idea of percent yield is going to be measuring our efficiency or how well our chemical reaction occurred. So we're going to be talking about theoretical yield, in theory how much we should produce, and then percent yield, how well did we actually do or how much did we actually produce compared to what we should have produced. So as we work, do all chemical reactions produce the calculated amount? And unfortunately, rarely do they do. Most reactions don't yield 100% of their product. We'll discuss this in our kinetics chapter later on as we're going. But for now, one of the ideas, improper lab techniques, we're going to leave us with one of our problems also leaving material in our beakers, improper weighing, improper heating. There are many different things that could go wrong just basically in our human error, along with the fact that reactions don't want to happen to completion. So two ideas where I have theoretical yield and our actual yield. Theoretical yield is the maximum amount that can be yielded from the given amount of reactants. This is determined by calculations, or it's the stoichiometric version. So this is going to be our math part. What we should get from the calculations. Actual yield is what we're going to do in the lab. So when we actually do our chemical reactions, and we're going to see how much we actually did produce from our lab by an experiment. So actual is our experiment, theoretical is our calculated amount of what we should get. To get our percent yield, we want to look at how efficient our chemical reactions were. And to do that, what we're going to look at is how our percent yield is the actual divided by the theoretical, since it's a percent, multiplied by 100. So efficiency is what we're going to be looking at. We know this is to be our percent yield. This is going to be the lab part on top, and this is going to be the math part on the bottom when it comes to calculating. So theoretical yield on the bottom, actual on the top. So our problem to look at this, excess potassium chromate, K2CrO4, is added to 0.5 grams of silver nitrate, AgNO3, and it's going to form silver chromate, AgCrO4. Determine the theoretical yield for silver chromate, so how much should we produce, and then calculate the percent yield if the experiment yielded 0.455 grams of silver chromate. So first step is we need to determine the theoretical yield of silver chromate, AgCrO4. So as we're working, our balanced chemical equation shows us 1 mole or 2 moles to 1 mole produces 1 mole and 2 moles. So to start us out, we started out with grams of silver nitrate. Now from here we need to go from grams to moles. So 1 mole of silver nitrate is equal to 169.88 grams of silver nitrate. Now remember, we get that from the periodic table. From here, we're now in moles. Grams cancel grams. We're now in moles of silver nitrate. Our next step is we need to do our mole to mole ratio. So 2 moles of silver nitrate to 1 mole of silver chromate. Moles cancel moles. Oops, 2 moles. 1 mole of silver chromate. And at this point, we want to get back to mass. So as we're going, 1 mole of silver chromate from the periodic table, 331.74 grams of silver chromate. So again, that's from the periodic table. Moles cancel moles, and we're left with forming about 4.488 grams of silver chromate. Now this is our theoretical yield. So our theoretical yield, that's what we would have done with our stoichiometry or our math calculations. Now, we produced 0.455 grams of silver chromate doing this in lab. So our experiment yielded this much. We wanted to make this much, so now we're going to look at our percent yield. So percent yield is our actual yield, I'm just going to abbreviate it AY, over our theoretical yield times 100. So percent yield, our actual yield, we actually produced grams of silver chromate. That's from our lab part, or the experiment. And the math part, in theory, we were supposed to produce, if it all worked, 0.0488 grams of silver chromate. Now at this point, multiplied by 100, we end up percent yield to be about 93.2%. So as we're going, we actually produced 93.2% of what we should have done. So depending on the chemical reaction, that's fairly efficient. So we should have made 100%, but we only made 93.2%. We call that our percent yield. And that'll end our Chapter 11 information as we're going. We'll continue to use this idea in lab to see how well we did our chemical reactions.